dear student, we will learn about in the previous chapter, in the previous lecture, capacitance of the parallel plate capacitor. C is equal to capacitance of the capacitor. C is equal to Q upon V. But here calculate the capacitance. C is equal to Q upon V. Capacitance of a parallel plate capacitor without dielectric and with dielectric field or medium kept between the two parallel plates. Consider two conducting plates or two parallel plates. They having one plate having a charge plus Q and another plate considered a minus Q charge accumulated on that plate. Due to the parallel plates, the air medium in between the gap where air medium is considered. Their air medium or without dielectric medium, the electric field intensity in the plates, in between the two plates, one having positive charge, another having negative charge, their surface area of the plates is considered as A is the surface area of the plates. Surface area of plates. And at the outside, the electric field intensity is 0. Electric field intensity is 0 at the outside of the parallel plates because of there is no charge, therefore electric field intensity is 0. According to that formula, C is equal to Q upon V. Therefore, electric potential Q is the charge accumulated on the charge plate A and B, and they having a surface charge density. Each plate having a surface charge density sigma. Sigma is surface charge density. Surface charge density. Sigma is the total charge accumulated by the surface area. Means Q, total charge upon total surface area is A. Therefore, sigma is equal to Q upon A. But here the electric field intensity at the outside of the charge plate capacitor, the electric field intensity or electric field of the parallel plates E is equal to sigma upon epsilon 0 because of two plates, sigma upon 2 epsilon 0 minus sigma upon 2 epsilon 0 at the outside, sigma upon 2 epsilon 0 minus 2 sigma minus sigma upon 2 epsilon 0 is 0. But inside the plates, electric field intensity in between the two plates, inside the plates, electric field intensity E is equal to sigma upon 2 epsilon 0. One plate acquires a electric field intensity sigma upon 2 epsilon 0 and another plate is sigma upon 2 epsilon 0 means sigma upon 2 epsilon 0 means sigma upon epsilon 0. Net electric field intensity or electric field in between these two plates is sigma upon epsilon 0. Now, what is the relation between electric field intensity and electric potential? In the previous lecture, we studied about E is equal to minus dV upon dx. Means E is equal to electric field intensity. E is equal to minus or negative potential gradient. Potential changes with respect to distance. The separation of the distance between these two plates is increased. Therefore, the dx is increases means potential gradient is decreases. Therefore, electric field intensity where decreasing the potential the distance is increases, their intensity will be minimum. Therefore, E is equal to minus dV upon dx means the potential is V in between these two plates and dx means d, the separation between the two plates is d. Therefore, E is equal to V upon d means V is equal to E into d. But here electric field intensity E is equal to sigma upon epsilon 0. Now we substitute that value. V is equal to E is equal to sigma upon epsilon 0 into D, where sigma is Q upon A. Therefore, Q upon A epsilon naught into D. Epsilon naught or epsilon 0. Therefore, the potential difference V is equal to Q upon A epsilon naught into D means V is equal to Q D upon A epsilon naught. Therefore, but by definition of capacitance of the parallel plate capacitor, now calculate the formula for capacitance. C is equal to Q upon V. Therefore, Q upon V, its value is Q upon A epsilon 0 into D. Therefore, Q get cancelled. Hence, C is equal to A epsilon naught upon D. When the air medium is kept in between the two charge conducting plates or parallel plates of the capacitor, then C is equal to A epsilon naught upon D. Capacitance of the capacitor is depends on area of the plates and distance separation between these two plates, D. And epsilon naught is the permittivity of air or vacuum. Therefore, the obtain an expression for capacity of the capacitance of the parallel plate capacitor when the air medium is kept in between the parallel plates. Then C is equal to A epsilon naught upon D. Therefore, when air medium is kept means C naught is equal to A epsilon naught upon D. For air medium, dielectric constant is K. Dielectric constant K is, for air medium, K is equal to 1. Hence, C naught is equal to A epsilon naught upon D. Now, similarly, we can calculate the value of capacitance of the capacitor with dielectric slab is introduced in between the plates. Now, we see the next expression. When the capacitance of a parallel plate capacitor with dielectric medium between the plates. Consider a dielectric slab is kept between the two plates. One plate is positive charge and another plate is negative charge. The distance of separation between these two plates is denoted by D. And thickness of that dielectric slab is taken as T. Thickness of the slab is T, where T is very small as compared to D. Therefore, T is less than D. Then we calculate the capacitance of the capacitor when dielectric medium or dielectric slab is kept in between the two plates. Their capacity increases or decreases. Find their expression. With dielectric slab between the two plates having a thickness T. Therefore, the net potential due to the polarization of the dielectric medium where negative charge is introduced or negative charge is formed on the positive side, positive plate of the capacitor, and its neighboring side is negative charge, negative polarized charge is kept. Therefore, the net electric field intensity in between the positive and negative charges, where air medium is kept, therefore it is denoted by E naught. Their electric field intensity E0 is denoted by electric field intensity, electric field between air of the two plates, of the two conductors, and electric field E or electric E0 is the external electric field. E0 is external electric field and EP is denoted by polarizing electric field or is the in outward directions. Their direction is different than that of the electric field. E0 is opposite direction. Electric field due to dielectric medium, the net potential difference V is equal to, what is the relation between electric intensity, electric potential and distance separation between these two plates? Therefore, electric potential, electric field intensity E is equal to V upon D. But V is equal to E into D. That formula is used to calculate the net potential produced when the charge conductor, the dielectric slab is kept in between the two parallel plates. Therefore, net potential V is equal to the electric field of the air is introduced in between the two charge plates. Its intensity is E naught into their distance. The total distance is D. Therefore, that distance is T. Hence, the distance between two plates means positive charge plate and one edge of the dielectric slab is T D minus T. E naught D minus T plus the electric field intensity E with the thickness of the dielectric slab into T. But when the electric field is opposite, therefore E is defined as E is equal to electric field due to the air medium divided by K. E naught by K. Electric field intensity E is equal to E naught upon K, where K is dielectric constant of that medium. Dielectric medium. Therefore, E is equal to E naught upon K. Hence, E naught into D minus T plus, substitute the value of E is E naught upon K into T. Therefore, E naught take common. Hence, D minus T plus T upon K. V is equal to the net potential between when the dielectric medium or dielectric slab is introduced in between the two plates. Therefore, the net potential E is equal to E naught into D minus T plus T upon K. Now, calculate the capacity of the capacitor. Therefore, C is equal to Q upon V. Therefore, Q upon E naught, where E naught is calculated, E naught is sigma upon epsilon 0. Therefore, sigma is Q upon A epsilon 0. Therefore, E naught is equal to Q upon A epsilon 0. E naught is equal to Q upon A epsilon naught into D minus T plus T upon K. Where Q get cancel. Denominator 1 upon A epsilon naught means C is equal to A epsilon naught upon D minus T plus T upon K, where D is the separation between the two plates, where T is the thickness of that dielectric slab and K is the dielectric constant of that dielectric medium. Therefore, C is equal to A epsilon naught upon D minus T plus T upon K. Consider if the dielectric slab is metal slab. Dielectric slab is a metal slab. For metal, consider the condition for metal slab. K is equal to infinity. For metals, dielectric constant is infinity. Air medium साठी dielectric constant 1 असतो. For metal साठी तो किती असतो? Infinity. Therefore, K upon K is equal to infinity. Substitute the value of infinity. Means 1 upon K means 1 upon infinity is 0. Therefore, C is equal to A epsilon naught upon D minus T. But D minus T, where T is very small for D. Therefore, T upon D is less than for 1. T upon D less than for 1. Therefore, T upon D means D is common. Therefore, C is equal to A epsilon naught upon D in bracket 1 minus T upon D. But T upon D is smaller than that of 1. Means C is equal to, but A epsilon 0 upon D is known as C0 or C naught. Therefore, C is equal to C0 times C0. A upon epsilon 0 upon D is known as C naught in bracket 1 minus T upon D. 1 minus T upon D. Their value is 1 minus T upon D, but T upon D is less than by 1. Therefore, its value is less than 1 means C naught, C is equal to C0 times increases its value. Hence, introduce the dielectric slab in between the two plates of the parallel plate capacitor. Their capacity is increases. Means C is equal to C0 times C0 upon 1 minus T upon D. Hence, their capacity is increases. Consider असा एक्झाम्पल लक्षात घेऊ. C is equal to अशी कंडिशन आपल्याला मिळाली. C is equal to C naught upon 1 minus T upon D. Where thickness is T upon D. T upon D ratio is half. Therefore, C is equal to C naught upon 1 minus half means half. Therefore, C is equal to 2C0. Their capacity of the capacitor is doubled than that of the air introduced in between the parallel plates capacitor. Hence, C is 2C0. Therefore, if dielectric medium is kept between the parallel plate capacitor, their capacity is increases.